Hello everyone, in this video I'll try to teach you how to run a CFD analysis for a heat transfer problem in transient mode. For this geometry, which I meshed it in the previous video using assembly machine. So if you want to learn it, please feel free to watch that video. But regarding our heat transfer problem, let me show you the inside of our geometry. So I kept my geometry because of the necessity for inlet and outlet and the assembly machine. But let me hide it, hide those surfaces. So our geometry comprised a rod, which is a hot rod placed inside the cylinder. So that can be a quenching problem or a heat treatment problem. So this rod is very hot. Let's say its temperature is 1000 degrees of Celsius, and we have air which is coming from this direction and exiting from that direction, and it's cooling this air, and we are interested to know about the temperature variation versus time. So the first step is to do some name selection. So what I'm gonna do, I'm gonna do name selection for interior of this cylinder, exterior, and for the surface body of the rod. So it's gonna take some time. So I'm gonna pause it and I'm gonna come back and show you how what I did. So I'm done with the name selection, and as you can see, I selected the interior of this cylindrical wall. I call it just pipe, and the exterior surface, rod walls, inlet and outlet, which I hid it, and then also I create a body name selection from the pipe or cylinder and the rod. And this is I guess a minimum name selection. Depending on your needs, you can break down, for example, this rod walls to different name selection. But for example, if you wanna monitor the temperature along the rod, you need to just select the name selection for the surface of the wall. But anyway, for my case, I don't need it. It's just for training. So with that, we are ready to go to the Fluent, and I'm gonna update it, and then I'm gonna continue in Fluent. So we are in the Fluent, and I'll start changing the setup from top to bottom. So this is transient analysis. I'm gonna check that. We don't care about gravity, so I'm gonna leave it unchecked. So this is a heat transfer analysis, so I'm gonna turn on the energy equation, and then we need to select a turbulence model. The default is on SSDK model, so probably I'm gonna leave it there, but you can select any turbulence model that you think it's appropriate for your analysis. So my mouse is kind of doesn't cooperate. So on the model, I think we are done. Then we go to materials, and so depending on your physics, you can change the material. So in fluid we have air, which we are gonna leave it as it is, and solid we have aluminum. And so depending on your problem, you can add other materials, but since it's for training, I'm gonna leave them as it is. So we'll go to cell zone conditions, and this is our fluid volume, which is created by assembly machine, and we just make sure this is air. So I clicked on that, and it's already it's selected as the air, and I'm gonna leave it as air. Solid, to make sure both pipes and then and the rod is selected as aluminum. And boundary conditions. So inlet, we select the inlet velocity. Let's select 10 meter per second, or maybe 5 meter per second. And then because we turn on the energy equation, we have a thermal section too. So it asks about the temperature of inlet, which is basically, we leave it as 300 Kelvin. Internal, so we have interior pipe, and let's just these are created by Fluent. Outlet, we don't do anything about it. Wall, that's something we need to check. So pipe inner wall, so that's why we did name selection to apply the required boundary condition. So for pipe inner wall, the thermal is going to be coupled, so it's going to be determined by equations. So we don't do anything regarding that. And this is a shadow. This is something that Fluent generated, and usually you don't do anything with it. You just check it, and it's a stationary wall, and thermal is coupled, so it's okay. Pipe outer wall. So we can apply just a convective cooling uh, to make it more realistic. It gives you different options. So we select convection, and it asks you about heat transfer coefficient. So we select 10, and free stream temperature, it's 300. It's ambient temperature. So we select OK. Rod wall. Uh, So again, it's the material is aluminum, and its temperature is determined by equation. So we leave it as coupled. This rod wall shadow, which we don't do anything about it, and wall pipes. This wall pipe, I don't recognize it. To see what's happening, I'll go to display, and then I check uncheck everything, and then I select this wall pipe. So basically, these are part of the inlet, and because we didn't do name selection, the Fluent already did it. So it asks us, okay, what to do with that. So what we can do, when we click on that, we can say, yeah, it's part of the exterior wall. So we can just leave as a via system coupling. Let's just leave via system coupling, so it's gonna calculate the temperature by equation. And we are almost done. Dynamic mesh reference values, we don't need to change it. Method, it's simple. I'm going to change it to coupled. I'm going to leave everything as it is. For controls, I'm going to reduce that to 5 because it's going to help for convergence. Flow current number, we're going to leave it as it is. report definition, it depends on what you want to get out of it. Usually you need to report the temperature of something in the simulation, which I'm gonna skip, and you guys hopefully know it. If you don't, you can watch other videos. So now we're gonna initialize it, but the key point is we want to make the initial temperature of rod like 1000 degrees, and Fluent is not very straightforward in this regard, so I'm gonna teach you how to do it. Let's just initialize it, and then you go to patch, and in the patch you select temperature and you select a value. So you want to select the rod value to 1000 degrees. So and then you select rod. So basically you assign this this value to rods, and then you patch. So it's gonna make rod 1000 degree, and then also you want to create a initial temperature for pipe. Let's just deselect everything, pipe, and the fluid as the initial temperature 300 Kelvin. So I'm gonna patch, and to make sure that it's correct, let's just create a plane, and to make sure this is the initial temperatures are created correctly. So we need to create a surface. So we go to surface and create basically a plane, and it's already created a plane which is crossed in the middle of the rod, and we are okay with that. So we're gonna say create, and then we're gonna go to graphics, contours, and we're gonna create a temperature contour from that plane. And yeah, so our beautifully our initial temperature is assigned correctly. So as you can see, this is a hot area, which is 1000 Kelvin, and the rest is a cold area. So our initial temperature is loaded correctly, and let's just initialize it. And but before that, we need to select a time step, and we go to run calculation. You can select a fixed time step, but usually we don't know what's the best time step, so we just select adaptive time step based on the current number, and the number of time steps when the current number is 1 here, and the number of time steps we can select 100 for now, but it's gonna take a lot of time, so so I'm not sure if I can show you the real result, but I show you the method. So I think everything is fine, and then let's just calculate, and let's see if I can show you any result. I'm gonna come back. So I let it run for 1000 more steps, but as you can see, the delta t is very low. It's in the order of 10 to the power of -6, and the total flow time is like 0.001 seconds. So nothing has changed that much, but this is a temperature contour that I got, and I'm sure if I let it run longer, it's gonna change. So